Hello and welcome to tribetopper.com.
You're watching this video on important concepts of electrostatics. In this video, we are going to learn about electrical capacitance and how we can find out the capacitance of a parallel plate capacitor. So now, as the name suggests, it is electrical capacitance of a conductor is basically its ability or capacity to store electric charge. So what amount of charge, electric charge, can a conductor store? That is its capacity or electrical capacitance. So what happens is that when we give some amount of charge to a conductor, its electric potential increases. And so if we go on increasing the charge, or we go on giving some charge to a capacitor, its potential goes on increasing. That means the quantities are directly related. That's Q is directly proportional to V, because if charge Q is given, then its potential increases by an amount V. So Q is proportional to V. When we remove the proportionality sign and add a constant here, the constant here is C, that is electrical capacitance. So this constant of proportionality actually gives us the capacitance, and the value of the capacitance depends on the shape and dimensions of the conductor. So whatever shape of a conductor we are using, depending on the shape, the ability to store charge would be different. So therefore, what is C? We can get it mathematically be defined as the ratio of the charge given to a conductor to the potential to which it is raised due to that charge. So Q upon V. And if we say that electric charge Q is given to it and its electric potential raises by 1 volt, right? So I give a charge Q and the electric potential, this is Q coulomb charge given to it, 1 volt, the potential to which it raises, therefore the capacitance is equal to Q. So we can also define that capacitance of a conductor is numerically equal to the electric charge that is required to raise its electric potential by 1 volt. And the SI unit for capacitance is farad. So 1 farad, we denote by F, is equal to 1 coulomb per volt. So if 1 coulomb of charge raises the potential of a capacitor by 1 volt, the capacitance of that conductor is 1 farad. Now we have a parallel plate capacitor here. So that's two conducting plates. They are placed parallel to each other and at a small distance, say d, between them. So when a charge plus Q is given to this plate and a charge minus Q is induced on the other side, and an electric field E is also set up inside the space between these plates. Now this electric field which is set up, E, is equal to dV by dr, because we know one thing, that electric field varies but it's a potential gradient, so it varies with distance, and since this field setup is quite uniform, therefore it would be equal to V upon D. Now we have done that electric field due to a charged plate or between a space between the plates is equal to sigma over epsilon naught, where sigma is the surface charge density of the charge or the plates. So between two parallel plates, E is equal to sigma over epsilon naught, and where sigma is charge per unit area because it's surface charge density. So I put this value of E here and I get E is equal to sigma over epsilon naught, and I would just replace the value of sigma as Q upon A into epsilon naught. Now that is the value of E. And therefore, from equation 1, V is equal to E into D. So we'll put this value of E that we found out. So it becomes Q over epsilon naught A into D. Now that's the value of V we have found out. Therefore, what is the capacitance of the parallel plate capacitor? By the formula, we know that C is equal to Q upon V. Put this value, we get Q upon V is Q D over epsilon naught A. Q would cancel out, epsilon naught would go to the top, and hence we get the capacitance of a parallel plate capacitor to be epsilon naught A upon D. See, from the dimensions or the expression, it is quite clear that because A is the surface area of the plates, so the dimensions of the capacitor determine what will be the capacitance of a parallel plate capacitor when these two conducting plates are held in vacuum parallel to each other. I hope you understood what's the meaning of electrical capacitance and how we can determine the capacitance of a parallel plate capacitor. If you find this video helpful, please like us, subscribe us and follow us on Instagram and Facebook at PCMisnoratta. Thank you for watching.
Please follow us on Instagram, Facebook and Twitter at TribeTopper.com.